Good morning, everybody. Today we'll be experimenting with the velocity limits of objects moving through portals in Portal 2. In the last video we saw that objects are slowed down by portals. Portals do impose some type of terminal velocity to objects that are moving through them. In this video we'll be exploring what exactly those are. We'll be using a console command to allow us to find out a little bit more detailed information about objects as they move through the game. To start off, we're going to go ahead, freeze time, get rid of the hard light bridges, and fly into position. Okay, let's let them fall. And I'm going to pause time and allow it to go extremely slowly. We can see that time is going very slowly. First off, we can see that some objects are getting stuck on the portals as they move through. They do get a little stuck. That's an interesting quirk. Not sure exactly what's going on there. Also, it's fair to notice that as objects move through the air, they are affected by air resistance, so they should be slowed down. We need to keep that into account. Take that into account when we get our results. Lastly, there is in the physics engine in Portal 2 a little bit of randomness going on. There's a little bit of randomness, so some of our numbers might not be exactly what we should be getting, but they'll be very close. Lastly, to find information about an object in Portal 2, I'm going to be keeping my cursor on the object, keeping those crosshairs on the object as it moves through the game, and then opening up the console, typing a command, and it'll give us information about it. Let's go ahead and do that with the next cube that comes out. Let's wait till it gets stuck. Let's see. Stuck. And now my crosshair is on the object, and I'm going to use the console command physics underscore debug underscore entity. Pressing enter brings us this information all about our object. We can see its mass, its inertia, its velocity, its angular velocity, and even how it's being dampened and what friction it's feeling. Let's pay attention to the line that says velocity. We can see velocity is given to us in 3 different dimensions. We have 3 numbers there. The first one is 1000, the second one is 0.98, and the third is 2.24. This is its velocity in 3 dimensions given in units, game units. These are actual units that the game uses to find out where objects are. These game units are different than the panels that we've been using. Each panel is made of 128 game units. So if we were to find the velocity of this object in panels, all we would have to do is divide by 128, and that gives us 7.81 panels. So our velocity of this cube moving through this portal is 7.81 panels per second. Okay, of course we could even still, that's with a velocity of 1,000 units, game units per second. We could use the 3-dimensional Pythagorean theorem to find out what its velocity is its absolute velocity. That would be, of course, a squared plus b squared plus c squared equals d squared being its absolute velocity. But in this case, 0.98 and 2.24 are so small, it's safe to assume that it would be basically 1,000 units per second. 1,000 units per second is the velocity limit for objects moving through portals in Portal 2. It is built into the game itself and cannot be broken in this situation. This is a weird, interesting quirk of the game, but also one that could come of some use. Maybe we'll see how later. Okay, everybody, that's going to be it for today. If you have any questions, comments, or concerns, please comment on physicswithportals.com or on the YouTube videos. That's going to be it. Take care.